This lesson focuses on combining functions. Now what that means is that you'll be given two functions. Let's say one function is called f of x and the other function is called, let's say, g of x. All right, so we have two functions. And basically when you're combining functions, we're putting two functions together. So you're kind of like saying you're going to put together, so to speak. Okay, so you're taking function f of x and you're taking function g, and you're going to put those two together. So meaning you can add them, and we're going to talk about that in a little while. You can add those two functions and you'll get a new function. So you'll get a new function. All right, so you can see how that's going to look. You can subtract those two functions from each other, and you're going to get a new function. We can multiply those two functions together, and you're going to get a new function. And we can divide the two functions, and we're going to get a new function. So when we combine functions, you're using the four arithmetic operations. So we can add, subtract, multiply, and divide. Now, one thing I got to remind you is that the order in which you add does not matter. The order in which you multiply functions does not matter. But remember, subtraction is not commutative, and division is not commutative as well. All right, so remember, these are commutative. Commutative. So the order in which you multiply or the order in which you add does not matter. Okay, now these are sometimes called the arithmetic combination of functions. So the arithmetic operations: add, subtract, multiply, divide. Okay. All right. So you can see what this is going to look like. But before we get started, let's remind ourselves about how to evaluate functions. So suppose that f of x is equal to 2x squared minus 5x plus 2. All right, so again, it's important you know what kind of function this is. So this is a quadratic function, okay? And let's suppose I want to find f of negative, let's say, 5. All right, so again, remember what that means. That means wherever you see the variable x, you're going to substitute negative 5. So if x is negative 5, you want to find out what that y value is, okay? All right, so wherever you see the variable, and it helps if you kind of use this idea. So you're going to get 2 times negative 5, notice I'm putting that in parentheses, and you're squaring that, minus 5 times negative 5, and then plus 2. All right, using the order of operations, I'm going to square first. So negative 5 squared is 25. 25 times 2 is 50. Negative 5 times a negative 5 is a positive 25. And then plus 2. And then I just add and subtract from left to right. So 50 plus 25 is 75. And plus 2 gives me 77. So f of negative 5 would be equal to 77. Now again, what that means, one of the things that means is that if you were to graph this quadratic function, you've just found yourself an ordered pair. So one of the ordered pairs on the graph would be, remember, x is negative 5 and my y value be 77. All right, so that's one of the things that you just found. Okay, now, so what's going to happen now is this. So you're going to be given two functions and you're going to be asked to either add, subtract, multiply, divide. Okay? Sometimes you're going to be asked to do that at a specific value for x, and sometimes you won't. So you'll see how that's going to look. But before we go on, let me just kind of mention to you something. So suppose I had these two functions. So notice that my function f of x here is quadratic. So that's that blue graph. And then the function g of x, which is linear, is this red graph. Okay? All right, now I just want to see if you remember how to do this. So I'm going to go ahead and expand this so you can see a little bit better. All right, now again, you can't see the colors, but this is teal green, whatever color that is, and this is red. Okay, now let's suppose, because this is the idea what's really happening. All right, suppose I want to find f of, and let me go ahead and say 2 plus g of 2. Okay? All right, so I want to find f of 2 plus g of 2. Okay, so remember, f of 2 means I'm going to go to my function f, which is the quadratic one, and I want to find what's the y value when x is 2, right? Okay, so I go and here's on the x-axis where x is 2, so I locate the point on the graph, so that's the point on the graph, and when x is 2, my y value is negative 6. So f of 2 is negative 6, all right? Then I want to find g of 2. So I want to add g of 2 to that. So I go back, and now I'm using the function g. So again, it's important to determine which one's the function g. So my function g is this line, this linear function. And so again, I go to the x-axis, I locate 2. I locate the point on function g, which is the line. So that's this right here. And I ask, and remember, you're trying to find what's the y value when x is 2. So my y value when x is 2 is 1. And so therefore, this f of 2 plus g of 2 is equal to a negative 5. Okay? All right, so let's do one more or a couple more just to give you the idea. So then, let's say you want to find g of, let's say 6 minus g of, f of 6. G of 6 minus f of 6. Okay, that's f of 6. All right, so again, I go to my function g, which is the line, and I'm asking myself, what's the y value when x is 6? So here's on the x-axis where x is 6. I locate the point on the graph, that's this point here, and I want to find what's that y value. Well, the y value looks like it's negative 5. So that's negative 5. Okay, so again, if you need a ruler to help you, go and do that. So here's where x is 6 right here. Locate the point. Here's my point. And then my y value is negative 5. Okay? All right. Now, I want to subtract from that g of 6. F of 6. F of 6. So here's my function f. So here's 6. The point on the graph is this right here. Okay? Right here. And so f of 6, so when x is 6, my y value is 10. And so therefore, negative 5 minus 10 is a negative 15. And then finally, let's say I want to find, let's say g of 0 divided by f of 0. G of 0 divided by f of 0. Okay, so I want to find this quotient. Okay, well, I go to my function g, which is the line. Okay, see it? And again, what's the y value when x is 0? So here's, remember, x is 0, the origin. So here's where x is 0. I'll locate the point on, and this is g I'm looking for. So I'll locate the point on the line. That's this point here. And again, what's the y value? Well, hopefully you can see this. The y value is 4. All right, now let's do f of 0. F of 0, so this time I'm looking at the quadratic function. And so what's the y value when x is 0? So on the x-axis, here's 0. I'll locate the point on the graph. And so that is negative 2 right here. And so I get negative 2 here. And so let's reduce if possible. And so 4 divided by negative 2 is a negative 2. So g of 0 divided by f of 0 is negative 2. Okay? All right, now, hopefully in a little while you're going to relate what we just did with what we're about to do. Okay, so here we go. All right, so again, we're trying to talk about combination of functions. So again, that's where you're going to take two functions. See what I did here? I took two functions, and I put them together. All right. So when I put them together, I got a value in this case because I was evaluating at a particular variable, at a particular value for x. All right. So you're taking two functions and you're putting them together. You're doing something with both of them. Okay. All right. So now there's some definitions we're going to look at, and so let's look at the definitions. Now, well, before I go on, you see how I wrote f of 2 plus g of 2? All right, so I'm going to come back to that, and the definition we're about to do, I'm going to relate it to it, okay? All right, so you saw from here that I can add, I can subtract, I can divide, and if you want to, you can also multiply, let's say. So let's suppose you want to find, I'm trying to find something that's going to give me a nice number. Let's say f of 4 times g of 4. Okay, f of 4 times g of 4. All right, so I can add, subtract, divide, I can multiply, right? All right, those are your arithmetic operations. Add, subtract, divide, multiply. All right, so f of 4, so again, f of is the quadratic function. So here's x is 4, here's the point. So when x is 4, my y value is negative 2. Times g of 4. Well, I want you to notice that these that f of 4, I'm sorry, that the graph f of x and g of x, they intersect when x is 4. See right here? So the y value should be the same. So when x is 4, my y value is negative 2. And so the product is positive 4. Product right here, positive 4. Okay? All right. So the combination of functions. Okay, so I can add, and so we're looking at the definition here. Definition of combination of functions. So again, we're looking at two functions. Let's say we have the functions f and g. So I'm looking at functions f and g. Okay. All right. So the first thing I can do is I can add them up. So we'll call that the sum. So sum. And so this is how it looks now. So sometimes it'll look like this. So it's important that you see this. So the notation. Make sure you look at the notation. The notation is going to be important. So here's a notation. So when I want to add these two functions together, I'm going to say in parentheses f plus g at x. So notice how I said this. F plus g at x. Okay? That's what this says. F plus g at x. Now that does not mean multiply, so don't think that that's multiplication. That's a very easy thing to misunderstand. So this means f plus g at x. Now, here's what that means. So these are the definitions. The definition of this notation means this. Means this. F of x plus g of x. That's what that means. Okay? So f plus g at x is f of x plus g of x. The difference, same thing. Except instead of add, you'll say subtract. So f minus g at x, f minus g at x will be f of x minus g of x. All right, now the order matters for subtraction. Okay, remember, in addition, addition is commutative, so the order does not matter. So you could have said g of x plus f of x. But here, remember, you subtract is not commutative. So remember, subtraction is not commutative. Is not commutative. Okay, so meaning 7 minus 6 is not the same as 6 minus 7. All right, so you notice that this is 1 and this is negative 1, so they're not the same. So if f is listed first, you got to put f first here. All right, so f of f minus g at x means f of x minus g of x. The other thing we could do, remember, is multiply. So we can multiply them. So this is going to be called product. So the product looks like this. F times G at X. F times G. Remember, if there's no operation, this one is going to be multiplication. F times G at X. And that means, just like this, what do you think that means? What do you think you're going to write this as? Well, if you said F of X times G of X, you're correct. And that, see how that looks right here? F of 4 times G of 4. Okay? And then your quotient would be division. So the next one's called quotient. All right, and remember how that looked when we did this right here. G of 0 divided by F of 0, right? All right, so quotient's going to look like this, though. It'll be F divided by G at X. F divided by G at X. And so that's going to be, remember, F is in the numerator, G is in the denominator. So again, subtraction is not commutative, and division is not commutative. So the order does matter. All right, so you can't say G of X divided by F of X. That's not the same thing. So remember, 4 divided by 2 is not the same as 2 divided by 4. Those are two different things. See, that's 2 here, and that's 1/2. All right, so they're not equal. So if F is in the numerator, F goes in the numerator. If G is in the denominator, G goes in the denominator. But that's going to be F of X divided by G of X. All right, so those are the definitions. Now, combination of functions is an easy thing. Almost every student does not have any difficulty with this. Okay, it's easy to deal with. All right, so how do we do this? All right, well, here's how it's going to look. So suppose, examples. Number 1. All right. Suppose f of x is this linear function, 3x minus 1, okay? And suppose g of x is this quadratic function, x squared minus 2x plus 5, let's say, all right? And I want to find each of the following. Okay, now listen carefully to this. See how this looks. I want to find a f plus g at x. Okay, f plus g at x. All right, well, let's think about that. By our definition, by the definition, this means f of x plus g of x, right? All right, well, let's write that out. So that means f of x plus g of x. Y'all agree? By definition? All right, now let's go ahead and substitute. Well, I know what f of x is. What's f of x? Well, f of x is 3x minus 1. So that goes here. See this? F of x. What's f of x? 3x minus 1. So put it there. Plus g of x. Well, do you know g of x? Yes, you do. G of x is this quadratic expression, this quadratic function. So I get x squared minus 2x plus 5. But you want to combine your like terms. And let's go ahead and put this in descending order. So I get x squared, 3x, and a negative 2x is a positive x. A negative, now let's do the constants. A negative 1 and a positive 5 is a positive 4. So therefore, your answer, here's how you're going to write this. You're going to say f plus g at x equals blank. You're going to say x squared plus x plus 4. Okay? All right, now let's go back and talk about what we meant by put together and what we meant by new function. All right, so do you see that individually f of x was this function, right? It was linear. Do you see that g of x was this function? It was quadratic. When I put them together, in this case, when I add them, I get a new function. So that's my new function for combining. See, I'm combining. Here's the word combining. I'm combining those two functions to get a new function. See, you're combining functions. You're combining functions using one of these operations to get a new function. And so f plus g of x is going to be this function. Okay? All right. Number 2, letter B. Okay, so let's suppose now I want to subtract them. All right, so part B, subtract. So let's say you want to find f minus g at x. All right, f minus g at x. Well, again, that's how it's going to look. You have to know this now. You have to know the definition. So what does this mean? What does this mean? Well, by definition, that means this. Okay, so that means f of x minus g of x. That's what that means. All right, now I'm going to substitute what I know. I know f of x. F of x is right here, 3x minus 1. So put that there. Put that right underneath f of x. Minus, now this is where you got to be careful, g of x. This is where some of you are going to make a mistake. G of x. Well, g of x is this, remember? All right, so I'm going to put that here. Now, listen to my words. The way I've written this is not correct because this says 3x minus 1 minus x squared minus 2x plus 5. But remember, this says right here I'm subtracting g of x. So I'm subtracting all of these terms. So remember, you got to put that in parentheses. So whenever you're dealing with the difference combination, the difference arithmetic operation, make sure you put that in parentheses. You don't have to put this in parentheses, but you're subtracting all of this. So you got to put all of this in parentheses because what's happening is this. So remember a while ago, you're subtracting all of these terms, whatever g of x is. So that means that all of these signs will change. So in other words, I get 3x minus 1. When I subtract x squared, I get a negative x squared. When I subtract negative 2x, I get a positive 2x. A negative times a negative is a positive. And when I subtract a positive 5, I get a negative 5. A negative times a positive is a negative 5. And then just like before, what do you think the next step is? The next step is combine like terms. And so let's put this in descending order. So I get a negative x squared, 3x and 2x is a positive 5x, a negative 1 and a negative 5 is a negative 6. So therefore, f minus g at x is this function, negative x squared plus 5x minus 6. All right, part C. Okay, let's look at part C. Now, in part C, let's suppose I had this. Let's suppose I had g minus f at x. Okay? G minus f at x. So the question is this. Do you think that this will be the same as this one? All right. Well, remember we said a while ago that subtraction is not commutative, right? So 7 minus 6 is not the same as 6 minus 7. So you will see that this, when I did this one, I got this function. When I do this one, it's not going to be the same. It'll be a different function because subtraction is not commutative. So that's what we get. So by definition, I put this first. So it'll be g of x minus f of x. Okay, so that's important to have seen this. G of x minus f of x. G of x, remember, is this. This is g of x right here. So I put that right here. X squared minus 2x plus 5. And I'm subtracting f of x. But remember, you're subtracting more than one term. So let's put that in parentheses because I'm subtracting all of these terms. Remember, that was the discussion here. So I can put that in parentheses. So I get 3x minus 1. All right, so then getting rid of the parentheses, I have x squared minus 2x plus 5. And then I have minus 3x. And then a negative times a negative is a positive, so plus 1. And then combine like terms, I get x squared, negative 2x, and a negative 3x is a negative 5x. 5 plus 1 is 6. All right, so g minus f at x is this. I want you to notice that, see how the terms are opposites of each other? Negative x squared, positive 5x, negative 5x, negative 6, positive 6. Okay. All right, now, so you now know that that subtraction is not commutative. You get different expressions. Okay, now let's do division. So let's say you want to find f divided by g at x. F divided by g at x. Okay, well again, by definition, what does that mean? You have to know the definition. You have to rewrite it. You have to know how to rewrite something like this. Well, remember, it's going to be f of x divided by g of x. So f of x divided by g of x. That's how you rewrite it. Okay, well, f of x is 3x minus 1. G of x is x squared minus 2x plus 5. Okay? All right, now let me just say this. If you can factor anything, then go ahead and factor. Whenever you're dealing, listen carefully, whenever you're dealing with the quotient arithmetic operation, you want to factor because sometimes you can reduce your factors. You can reduce your common factors. But it turns out that you cannot factor this, and this is not factorable, so you're done. Okay, but Jim, put this in as a little note, factor if possible. Factor if possible. I'm going to put for quotient. For quotient, factor if possible, and reduce. Okay, but if you notice that you can't factor it, then leave it like this. All right, so that's f of x, f divided by g at x. That's what this is. All right, now let's look at the product. The product's going to be a little bit longer, so I'm going to go ahead and you'll see why. So I'm going to go ahead and put this on another page. So let's look at the product. Let's say I want to find f times g at x. F times g at x. Well, remember, f times g at x means f of x times g of x. That's what that means. Okay? All right, now look how I'm going to do this. It's important. So f of x is this. Right here, right? 3x minus 1. So I put 3x minus 1 up. Now, listen carefully in a little while. Times, and put times right here, g of x. Well, g of x is this trinomial. X squared minus 2x plus 5. Now, you got to be careful. See, the way I've written it is not correct, and here's why. You want to multiply these two functions. So, the way I've written it, all you see is this, -1 times x squared. That's all you see. And that's not the only thing that's being multiplied. So you need parentheses. So this times this. Okay? So that times that. Now, you do have to multiply this out. Yes, you do. Just like when you had the quotient one, you had to factor if possible. And then reduce. So yes, you do have to get rid of the parentheses. Yes, you do have to get rid of the parentheses. Yes, you do have to get rid of the parentheses. All right? So here we go. Now, you cannot use the fall method here, so you got to remember how to do this. When you have a binomial times a trinomial, here's the way to do this. You take each term of the binomial. You take each term of the first factor and you multiply by the second factor. In other words, you're going to say 3x times the second. Remember, these are two factors. First factor, second factor. So you take each term of the first factor, multiply by the second factor. So you're going to say 3x times this minus 1 times this. Okay? So each term times a factor. So 3x times this, see how it looks, 3x times this, and then minus 1 times this. And then you distribute. That's all you do. Distribute. Distribute. So I get 3x times x squared is 3x cubed. 3x times a negative 2x is a negative 6x squared. 3x times a positive 5 is a positive 15x. Over here, negative 1 times x squared is a negative x squared. negative 1 times a positive 2x is a negative 2x is a positive 2x, and a negative 1 times a positive 5 is a negative 5. And they combine like terms, I get 3x cubed, and let's put it in descending order. A negative 6x squared and a negative x squared is a negative 7x squared. 15x and a positive 2x is a positive 17x. And that's the only constant, so I have minus 5. Okay, so my new function is this. So I put those two functions together by multiplying, basically this. I put those two functions together by multiplying, and I got a new function, and that's this. So it's a cubic function. Okay? All right. So you would say, as the answer though, you would say f times g at x equal blank. And in the blank you would say 3x cubed minus 7x squared plus 17x minus 5. All right, now make sure you show the work though. And make sure I can understand from step to step what you're doing if you want to get your full credit. Okay, now, so this, all we've done here, now listen carefully, all we've done here is discuss what we mean by combining functions. All right, what we mean by combining functions. All right, so you need to know the definitions. Now, before I go on, I want to remind you that in a previous example, we did this. So remember, here I evaluated at a particular value. See here, I didn't evaluate at a particular value. I just said, let's go ahead and talk about how to find f of x plus g of x, right? Okay, so in the next lesson, the one right after this, we're going to talk about how to find, so next lesson, we're going to talk about how to find, let's say, f plus g, not at x, but at, let's say, 4. F plus g at 4. But the definition still applies. You're going to say, instead of an x here, it's a 4. So you're going to say, well, that's going to be f of 4 plus g of 4, right? All right, and then remember how we do this? F of 2 plus g of 2. It's given a graph, but in this case, the graph won't be given. It'll be the expression. All right, so that's what we're going to do in the next lesson. All right, so that's going to end this lesson on combining functions, on just combining functions, just like this. That's in that section. The next lesson, it'll be at particular values for the variable. Okay.